Welcome, everyone. Thank you so much for joining today for Vibe Coding for Healthcare 101. My name is Steph Chia. I am the Senior Research Manager at the UBC Department of Medicine. I also help manage the UBC Data Science and Health, or DASH, research cluster. So if you are not familiar with DASH, I hope that you can check out our website, as well as sign up for our newsletter, and you can stay up to date with all of our activities and future events, and come to future webinars like the one we have today. So before we begin, I would like to acknowledge that we are hosting today's meeting from the UBC Vancouver campus, which is located on the traditional and unceded territories of the Coast Salish peoples, and including the Musqueam, Squamish, and Tsleil-Waututh First Nations. I am very grateful to be living and working here, as well as for the enduring stewardship of the traditional caretakers of this land. We hope that you have enjoyed our first two sessions of Vibe Coding for Healthcare. So session one was, what is Vibe Coding and why does it matter for health? And session two, building research tools with Vibe Coding. But if you missed those sessions, not to worry, we have recorded them and they will be shared through our Dash YouTube channel. And at the end, Omar has provided a really great website for you to find all of the things that we've learned throughout the series. So today is our third and final session of Vibe Coding for Healthcare 101, building clinical and operational tools and where to go next. So today we're going to continue to explore various examples of clinical and educational tools that can be built, as well as deployment basics, privacy and regulation considerations. And at the end of today's session, you'll hopefully have a great roadmap for you to build your own clinical tool. I will be passing it off to our presenter and expert, Dr. Omar Salim. So thank you, Omar, for guiding us over the last two sessions and today as well and sharing your expertise. Before I pass it to you, I do want to share our Slido QR code. So if you have any questions throughout the presentation, please go to slido.com and you can enter the code there or navigate there by the QR code. And we'll collect all the questions and it'll save time to go through all of them at the end or maybe throughout the session as well. So I'm going to stop sharing now and let Omar take it away.
Awesome. Hi guys. It's nice to see everybody again, and I really enjoyed the last two sessions, and it's been a lot of fun. It's as much of a learning process for me as it is. I hope for everyone else. So really enjoy it, and thank you for giving me the privilege to do it. So just wanted to start with kind of where we left off last time. So we did a lot last time. We spoke about different kind of research tools that are available. There are skills that we can build and we can use as a way to kind of improve reproducibility and reliability of platforms, and also skills that can be exported to be used on at scale. So if someone else is building apps, you can give them the skills so that they have a blueprint as to how to build them. And then we built out an almost agentic kind of research app, which had an abstract and it had different components in there. And I made some improvements on there, so it's much more educational on there, and we'll go through that at the end just so everybody has that available to use. And so today I wanted to kind of bring it all together. So it's much more focused on clinical AI tools, but initially when I was thinking about this, okay, I was like, okay, maybe we'll work on this tool, or maybe we'll build out this kind of app for clinical use. But the more I think about it, and especially the more like vibe coding evolved into agentic AI and in different components of AI, it almost doesn't make sense to focus on one narrow niche because everybody's narrow niche is very different. So if we build today a sidecar that has different components, then it's very different from a need that someone else might have. It's the problem they have if they're a clinical researcher, if they're in informatics. So what I wanted to do was more focus on the framework and focus on how it is that we can apply clinical tools and how I like to think about it. And basically, we'll build out a whole toolkit for different things, and I'll add all the different components that are usually available. And then if you have a problem that you are having, we can maybe break it down and go through and solve it together. And then we can do a build at the end. I've done a couple just to kind of showcase showcase the use case. And I did want to focus a lot about on the cultural aspects because I know British Columbia is extremely diverse. I've been to Vancouver; it's one of my favorite cities in the world, by the way. But it's extremely diverse. So multimodal AI is very useful in this. Translation is very useful in this. So that's kind of where I wanted to go with that. So the like we spoke a little bit about the screener that we made at the beginning, the research workflow that we made at the middle on in the last session, and then now we'll focus on the clinical tools. So when you think of clinical AI tools, there's four layers that I like to kind of break it down in. And the base layer is what we call the reasoning layer, and this is what everybody knows. This is ChatGPT or Claude or Gemini, whichever one you may want to use. And then you have the knowledge layer. And the knowledge layer is a little bit more robust, a little bit more expansive. And the knowledge layer is, it can be something like just kind of like knowledge that, like a good example is what UBC may have as far as all the different research papers that they publish. It could be PubMed, like we did last week, where you can extract different information for PubMed. The third component within this is called clinical decision support tools. So clinical decision support tools are kind of like open evidence and up to date. So up to date is basically a repository that has different guidelines as to how patients are managed. Open evidence takes that to another level with using AI tools. We hormonally is another one that we have. So hormonally basically is more for modern medicine using new research that comes about and absorbing the new research for it. So these are all knowledge-based tools that can be plugged into a platform or an app or just on anything that you might be using. So even think of it like if you have ChatGPT, that can directly connect with a knowledge tool, and that's all you need. You don't need the third interface layer or deployment of the full app. So that's why I like to have it as a second layer in the layer and then in the stack. And then the third is the interface, and the interface is kind of what we did last week was basically in the app itself. So how things are seen, where things are coming in, when are they coming in, when is the LLM kind of getting involved? So that's the interface layer, and the third and the last one is deployment. So deployment is like where does it exist? Is it as a front facing mobile app? Is it as just a web app? Or is it something that just lives inside as an infrastructure rather than as a front end? So this is something like an AI agent. And so that's kind of the different ways to kind of stack it up. And I like this framework because then it sometimes you don't need to go up all the way to layer four. Sometimes just going to layer two is enough from a cost perspective, but also from just the ability to just make something get good results. That is also useful from that perspective. So the reasoning engine is essentially what we kind of spoke about. So this is Claude, GPT, Gemini, Llama, which is now soon to be Manus for Meta. And so these are essentially the models themselves. Models themselves are starting to be more and more just pure reasoning layers. And what that means is they're starting to become very light. And by light, I mean they are basically orchestrating while they access certain information. So that's think of it kind of like it's having a brain without a body. And then the spec to app builders that we have. So these are the replets, the lovables. So replit is what we used last week. Claude Code, Codex. These are kind of the brain with the actual body, and they can do things, and they can ship things. They can extract information. They can access the internet, and have more utility. So, like I've been, I think my philosophy with this is just pick one, and you'll and just really understand it, really know it well. If Claude is something that you like, then just go with that. Go with Claude Code, learn Claude Code, learn Claude Cowork, and same with Gemini as well or GPT. Each one does have its strengths and weaknesses, and we'll talk a little bit about that. But it's kind of it is better to focus on one area. Eventually, what will probably happen is they'll be interchangeable, and we're already seeing that with tools like OpenClaw, and Replit is another good example of that, where Replit and Lovable now switch between Claude, Gemini, and GPT to get the best result that comes through. So yeah, so that's the bottom layer. Second layer is the decision support or the knowledge layer that we were talking about. So the knowledge there is important from a medical perspective, primarily because this is where we get a lot of verification and validation. So if if we're doing any kind of clinical tools, having API access to open clinical data like we have with OpenFDA or PubMed, clinicaltrials.gov, this is extremely useful. Same thing with having the decision support. So this is Glass Health is a good example of this, where you have an API that can plug into your app, and it can provide a lot of the guidelines. Same thing with open evidence, as we know, and hormonally we discussed as well. And then the third one is RAG, and this is your own knowledge. And this is I want to spend a little bit more time on this because if institutionally someone wants to build an app, a good way to do it is do a RAG system. And basically, what RAG is retrieval augmented generation, and what that is the AI is able to only access your corpus of information. And by accessing your corpus of information, you're able to create guidelines, guardrails, and also safety. And so this includes protocols that there might exist in a department, or different order sets that are available for patients to use for patients, and also papers that are available in an area, or patient handouts. And this also allows for reliability, where if someone sets up a rack system, they know that the AI is not going to be thinking from or hallucinating from left and right to come up with a solution, or an answer. So that's where it's extremely powerful. So usually a good setup is where a RAG kind of forms the source of truth. On top of that RAG, we can add in the more knowledge bases. Like a good example is if we want to make a order set, like an order set intelligence system, the RAG will make up all the order sets that are available in a hospital or in a facility. So that way you know that this is available versus this is not available. So it's not going to bring up order sets that are from, say, a different facility in a different location, or make up medications on the fly. And on top of this, we can add a decision support layer where an API gets pulled in for open evidence. So it's like, okay, these are the medications we need to use in this kind of. So say someone comes in with like a pneumonia, it knows that these are the antibiotics that needs to be used, and the RAG will pull in exactly the order set that are going to be used for that case. So it's a combination of those two that really gets very effective. And then third is, of course, the clinical data pipeline. So another good example is medication interaction. So OpenFDA has a really good medication interaction tool. So that can also be brought in, and any time that order set is pushed, it can check and if there's any kind of medication interactions that are happening. So that's how these come together usually, and this is all being orchestrated by the LLM underneath. So that's the knowledge layer. The next one is this is the input. So the input can work in different ways, and this is an area where we're starting to see more progress being made. And the reason is that for the longest time since ChatGPT came out, we've basically been stuck in a text. Everything's been a chat box, and it's starting to slowly change. OpenAI Real Time came out earlier this year, which is basically really fluid voice interfaces for LLMs. And slowly we'll start to see this evolve. Already last month, Andre Karpathy, I had mentioned him earlier in the first session. He actually came out with another tweet, yeah, a couple of days ago, that's kind of what his declaration was, that we're now seeing a transition from text-based into a more visual-based AI interface. And if you remember apps and the internet, that's actually how the internet kind of evolved, whereas initially HTML was all there was in the internet without any images. And the internet really got big once images and videos started to get big. So that's the kind of stage that we're seeing, especially this month. And so it's important to kind of think of inputs from that perspective. So inputs are text is probably the one that we know really well. Voice is another one that can be integrated. This is especially important for where areas of lower literacy are there, where I have a lot of patients here who are Spanish speaking. And so you can connect a lot of APIs through Gemini or OpenAI real time and talk to them in Spanish and having them dictate what's going on, and it populates it automatically in English. Same thing the other way. So if there's a diagnosis and a plan is made for treatment, that can also be translated into their language of choice. And we'll talk a little bit about that from a BC perspective, especially because I think that that's very important. And then the third modality is imaging, and imaging is very important, primarily because medicine is so heavily imaging based and it's becoming more and more imaging based, where you have EKGs, you have PDFs, labs, and X-rays, and CTs, MRI. So all these things can be converted into something that can be a knowledge base. And so multimodal LLMs like Gemini are extremely powerful for that. So that's another important nuance of matching that input to the workflow. Is that if, say, you're doing imaging based tools, then using that multimodal LLM becomes more powerful on in the stack. And the third is ambient. So ambient is just present. So ambient is something that we're heading towards, where it understands kind of what's going on. It formulates a plan of its own and kind of decides that and kind of takes it to that next level. So scribes are the best example of this, where we have something like Heidi, where you have a conversation with a patient. No one knows that, or no one, everybody knows, but no one realizes that the LLM is there, and it comes up with a plan. And now they've started to do more decision support as well. So that's becoming more and more the case with ambient scribes. So that's the fourth modality, or the highest level that we can take that. Now, so the that's the fourth layer, and then so this is something so whenever we kind of start to make a clinical tool, there's certain elements that we have to kind of be wary of that are extremely important, especially because, and I think this is something that is extremely important, primarily because we're able to make these tools, but as shepherds of clinical care and for patients, we have to be the ones kind of managing this for them, and because a lot of times this is something that we don't realize that it becomes important, but it yeah, for so essentially like it's hard for patients to sometimes understand the value of these things. So one of those is transparency. So just having, like, this is, we're using an AI, just to tell them that you're using an AI to build these tools. That's very important. Accountability. So basically, when you build a tool, it's you as a physician who's responsible for that tool. Same thing like if you were to write an order for medication, or if you were to do a treatment plan, it's you as a physician who's responsible for that. And then the third one is beneficence. So that's just to see like who is it that we're helping, and is it something that the patients are really benefiting from, or is it something that the institution is benefiting from? So just to have clarity on that, that is this something that will benefit someone, or will it harm? So sometimes there are tools that can give inaccurate diagnoses or hallucinations. Those can be very harmful. So that's something that to keep top of mind. And then the other ones are cultural safety and just having culturally tailored care. So this is extremely important because many models have a lot of blind spots when it comes to data, especially from indigenous populations, minority populations. So those sometimes get lost in those blind spots. I actually have a big focus on South Asian care, and a lot of the models I've tested have the benchmark is almost 20 to 30% less when it comes to South Asians, because there isn't a lot of data on those populations. So I'm sure with say an indigenous population, that's going to be even worse, or even less. So that's something to keep in mind, and that's where being aware of this and being a leader in this is very important, because that's the only way that those populations end up getting represented. Because as AI becomes stronger, as we have digital twins, simulations, though these components kind of will only magnify. So it's important to kind of keep those in mind and work on those. So that's and then the last one is equity. So the same along the same line. So basically, training data. A lot of what is represented in EMR sometimes can be there's a lot of gaps. There's a study that came out last year in Black Americans, where it showed that the LLM was modeling them as to using less care, or that they don't use as much care. The issue was that they actually were not getting the care that they needed, more so than that they were using less care. So I think things like that have to be really accounted for. So that's why when we build these tools, we have a privilege in building these tools, but it has to be done the right way. So that's something I wanted to mention. I didn't think it's with great power comes great responsibility. So that's an important component. And then now this, I wanted to focus a little bit more on BC specific kind of governance. I live in the US, so I'm not as aware of those, but it's there's different kind of layers to that. So you have the federal layer, which is more in the private sector with the PIPEDA, and I've worked with a few apps like integrating PIPEDA. It's challenging, but it's something that can be done, and just to be aware of that. And then same thing with researchers. If you're doing any kind of research, there is a Health Canada framework that can be used, and also there's a certain policies that have to be followed. And then the one I think was most relevant here is probably going to be the FOIPPA, which is something more focused on kind of health authorities and kind of like any kind of public research that's done in population data. So that's something that I wanted to mention is just to be wary of kind of where you're building the app. The regulations always apply to the location where the care is happening. So just to be wary of that is very, very important. Um, and then lastly, again, so this is another component, and I'm very passionate about that, as you can tell, because I this is a big focus of mine from an AI perspective as well. So like indigenous data, it has to be just the representation of that. So from what I found in my research is that there's just four different frameworks for it. Just to make sure that you keep up with that, as to make sure that that is also included in the data, because there will be a lot of times where different recommendations from the LLM will be very much geared towards certain population that maybe is not the population at hand. So there's different ways to put guardrails in there, and we can build AI skills in there that actually have those kind of contingencies. So this is more for as a reference. So and I'll put this slide up. So this has like kind of what we spoke about before, all in one place, and kind of take it from there. And then one thing I wanted to mention that I didn't mention earlier was human in the loop. So when we're building clinical tools, it's extremely important to keep a human in the loop when it comes to the final decision making. And the reason for that is LLMs are still very new. We don't know as to how they behave. They might seem like supercomputers on one end, but they're very very low IQ on some other very common sense things. So like there was an example last week or last month where the LM was asked like, should I walk to the car wash or take my car to the car wash if it's down the street? Actually, the LM said you should walk to the car wash, even though the car is going to be staying at home. So things like that. So imagine like if it can make errors like that with such examples, and in medical cases, it can really have a lot of blind spots and miss things. So human in the loop is very important. Anytime we make a framework, human in the loop has to be the final decision making when it comes to patient care. Now, lastly, we spoke a little bit about multimodal tools. So especially for any kind of population that's very diverse, so different ways of using multimodal tools, and our language is one of them, voice is another one, and we spoke about both of those a little bit as to adjusting those. The third one is vision. Vision is really cool actually. So vision can be used in multiple ways. So normally when we talk about vision, we think about EKGs, diagrams, labeling, but also teaching patients. I think teaching patients we use vision models to teach. I like to use Gemini to make diagrams and explain to patients in their language. So like if they say they enjoy sports, so you can use soccer as an example to teach a concept to them. Or another one is if they're taking medications, we can kind of show them different places where these medications are working and helping them. So that's a very, very good use case. Secondly, vision is also very useful when it comes to just in general. So a good example is using it for like dermatology. So real world use cases, real time use cases. So dermatology is a good one. Eye like ocular health and optic health is another one. And I think there's more and more use cases coming about. Now we're actually able to do vital signs using vision. So that's going to be a big focus as to using those tools to bring into an app that you're vibe coding or building out. And vision can be a big component of that. Yep. So just to recap, so we spoke a little bit about kind of the the reasoning side, which is your LM and your models, the knowledge side, which is like the toolkit, the toolkit that has like up to date, open evidence, clinical decision support, and then also lastly like open tools like clinical trials and also medication interactions. And then the third layer is interface. So interface is basically where the where all of this happens and where all this takes place. Last one is deployment. So deployment is basically where this will be seen. Is it going to be a mobile app? Is it going to be a web app? Where will this happen? So yeah, so that was kind of what I wanted to talk about quickly, really quick, and then just wanted to mention. So we also will be having an AI in healthcare certification, which we partner with GCLS, which is Geneva College of Longevity Sciences. So if anyone is interested, we'll be having that as well. So now I wanted to go into building. So I built out a few different things just to have different use cases. And this one is essentially a patient translator. So one thing to note is that in this, I built it out, but afterwards I was thinking like as far as PHI goes, it's very important to not put any kind of patient information in there. So that's one thing to note. The other thing is like as far as adding in images, things like that, that should also not have any kind of patient information. That's also very important. So the goal with this app was basically to build a clinical patient translator, basically take any document that they have or any medical history that they have, and it translates it to a targeted reading level. So it basically takes it, if someone is at like a fourth grade reading level, then it can translate to that. And then if they want to or if they speak a different language, you can translate towards that. So let me try. Hmm. We'll come back to this. I'm looking for the documents, but I can't find the actual document. So this was the second one that I built. So this was essentially a clinical, kind of like a clinical assistant, a Socratic tutor almost for any kind of case that someone was having on the ward. So if they saw a different patient with certain things, so this would basically teach them about that patient. So and then it learns from how they're doing. It learns to teach them, and then the other thing that it does is that along with teaching them, they can also, if they have any interesting cases that they have, or if they have any kind of different problems that they're having, they can add those in. It also has practice questions. So this is kind of bringing in the four layers. So if you were to have the bottom layer of the LLM, the middle layer, which would have like your knowledge. So this is connected to PubMed, which you can bring in all the research. This is connected to right now it's not connected to, but we can connect it to Glass Health, and it'll bring clinical decision support or hormonally if they want to learn about regenerative medicine. So those tools are there, and then on top of that, then it has the interface, which is the questions, and then lastly, it's deployed as a web app. And the nice thing about this is like, say there's a question set of in training exam material that they have that they want students to learn from. So what we can do is we can basically say, let's I have a few PDFs of questions and learning material that I want to ensure I learn. Can you help me build and teach me? So this would basically take, so say is an in-training exam or USM, like we have the USMLE exam. So things like that, it can become like a smart tutor for that. And then if they want to add like flashcards to this, we can add flashcards in there. If they want it to be MCQ based, we can do MCQ based, and then it trains them based on those. So I'll for now do MCQ, and then and yeah, so and then it'll save it to the database. It'll keep those there. and they can learn from it. And essentially, that's the goal of this. So essentially, it's a clinical kind of assistant that, as they have interesting cases, as they have different questions that they're training for, then it can do that.
We do have one question,
Sure.
which is how do you set up a RAG with a person's own references or data?
Yes. So that's a good question. So with a RAG, you can do it two ways. So if you're using Replit or Lovable, these kind of one-stop shops, they can set up a RAG for you. So Replit and Lovable both have a database underneath. And what you need for a RAG is actually a database that converts that information. So let's say we have a PDF of questions, or we have a PDF of content for internal medicine. That content is then uploaded into a database through what's called embeddings. Embeddings are where the LLM converts that information into certain spots on a graph, and it puts things closer together that are closely matched together, and it's what's called chunks. And these chunks are basically placed on a vector graph in a three-dimensional space almost. And when the LLM wants to know something, it retrieves those three-dimensional spaces. So what you need to do that, to keep it short, is a database that supports that vectorization of the data. So the easiest way is to do it on Replit and Lovable. But if you want to do it, say using Cloud Code or Codex, usually you need a database. So the easiest one I would recommend is probably either DuckDB. It's called DuckDB, or Supabase. Supabase is very easy, and the reason I mentioned those two is because those can directly integrate into the Cloud Code or Codex. So they can communicate with each other, so you don't have to do any kind of setup. You just connect them together, and then they'll talk to each other to set everything up. Versus if it's more Google Cloud, you can do that as well, but setting up Google Cloud is still too complex. So that's why I probably recommend those two. And then and all you have to do is upload all that information to Cloud Code or Codex and upload the documents in there, and it'll automatically make a RAG. The other way to do it, and this is kind of like a crude way of making a RAG type of system or source of truth, is what we kind of did like last week. I had mentioned Obsidian. So Obsidian is essentially a data is a store of markdown files. So if you have a lot of documents that can be converted into markdown files, and markdown is a language that LLMs speak really easily. So if you can convert, like, say, a ton of text into markdown, that text can then be pulled by the LLM instantaneously. So it doesn't have to convert it into an embedding or a vector. So from a personal perspective, that's a little bit easier. And I'll put the link to Obsidian here. And so this is Obsidian, and I can demonstrate that as well. So this was a little bit out of the scope, but if there's interest, I can kind of go over how to kind of set up how I set up Claude at least, or Codex, and how it kind of goes through and connects with everything. If anyone's interested in that. So basically, let me share. I'm actually going to share my whole workspace. Here we go. Okay, so this is Obsidian. So essentially, I have multiple AI agents as well. So I wanted to show kind of how my Claude, my Codex, and my AI agents are all come in and connected to this one place. This is a little bit outside the scope, so it might be a little bit complicated. But so essentially, in Obsidian, they all have a kind of like a soul file. They have the kind of who they are, what they do, and all these agents, and this is their identity. And then they kind of, this is their source of truth. So this is their memory, not even their brain, but their memory and their context. So that's kind of where they come in. And in Obsidian, you can add more and more of these. And then also I have, like, to give you an idea when it comes to like so this is if we go into Dr. Vibe, I'll show you. So this is kind of like we were working on the webinar today. So like all that stuff is in there, and then the skills are in there, and then the so if so just to help somebody if they want to set like structure their Claude code or codex, I would use Obsidian and just have it organize it this way where you can just tell it, okay, this is how I want it to be organized, and that'll be the source of truth for that. So that instead of RAG, this is another way to do it if you would like to. Sorry, it's a very big tangent. And so yep, so and then let's go back to the build. Okay, so it's still working. This is why I like to build them out earlier beforehand. So another thing that I wanted to build out that I'm not sure if it's done, was so something I wanted to talk a little bit about was um, the like when we build clinical tools, it's essentially integrating different components that are even outside of medicine. So, and it's something that we can try to build if you would like to, but essentially, so a good example is if we have so in British Columbia, if there's an increase in certain kind of pertussis cases, or a certain kind of increase in reactive airway disease cases. So one thing that we can do, and it's very useful from a research perspective and a clinical perspective, is bringing in outside resources that previously was never possible. So what a good example is Google Maps API. So Google Maps API actually has pollen data, it has traffic data, it has congestion data, it has environmental data. So that can also be brought into an app, and if the region is seeing increase in certain, or the hospital has best real-time data, so if you're seeing more cases of certain things, Google actually has all that data all the way back, I think 20 years now. So that can be traced, and data can be processed through that and presented, and the LLM can understand it and anticipate almost. So that's something that wasn't really done before because the cost of doing that was very high before. So with this, it can be done. We can set it up within minutes if we have the APIs. The other one is the other thing that kind of came to mind was basically like an app to help convert different documents and images to from different languages. So if someone's coming internationally and they're visiting, you can also make an app to kind of convert those documents into English. Of course, we'd have to remove the PHI from that before doing that. So that's another use case. And let's see. So let me see here. My screen is blocked. Here we go.
Maybe can you go through some of the prompts that you used to get to this stage?
Yes, I think that's a good way to do it. So let me start with this one. So the best way to do it, so say you have an idea that comes to mind, and actually that's a great kind of place to go, is if you have an idea for something that comes to mind, that what I like to do or what my process is essentially starting with Claude or ChatGPT or Codex, and from there taking it, is this something that I can build? And then going through the mental kind of math of if I do this, what would it look like? What would the process look like? And so, and then kind of talking to Claude through that. And then once it's like, what components do I have? And giving it the context, okay, I'm in British Columbia, or I'm a certain type of physician, and I do all these things. So then Claude will break that down as to what you want, and then ask it, can you make it into a prompt for Replit that I want to use? Once you do that, it'll give you the exact things that are needed, and then once you put it into Replit, then it's easier to kind of build that out one by one. And one can take this both ways, where you can have you can build it out in Replit. The only thing is that the cost goes pretty high if you're doing that. So if you're going back and forth with Replit and building something out, so this took about $3 to build out just with one prompt. If you were to do multiple prompts, it would take almost like $15 or so. So that's the reason I like to do the refinement in Claude, and then you use Replit. Another thing I want to show was the like the stack and things like that. So one thing to know is with the different kind of stack that is used, Replit tends to lean more towards React, which is a good stack in terms of it looks really nice. But the problem with React compared to like Next.js, which is a different format, Next.js tends to be a lot more scalable. So for very production heavy tools, Next.js is a better option just because it's more reliable, it's much more oriented towards data. So if you're dealing with a lot of data analytics, informatics, a lot of research, then Next.js is a much better platform for long-term build. React is really good if it's like very quick, needs to be spun up really fast. But then it's not needed anymore, then React is a better option. And then for the LLM providers, this is another important kind of thing. We touched about it a little bit last week with cost. So when it comes to LLM providers, there's of course ChatGPT or GPT 5.5, Claude, and there's also Gemini. But I like to use OpenRouter, and the reason I like to use OpenRouter is because OpenRouter also has the outside LLM. So not just the three, but it has the open source LLMs. It has the LLMs made in China, and the reason that's important is cost, but also it's important because that allows you to be fast or make a quick app, fast app as well. Like GPT has 5.5 mini, it has 5.5 nano, but there are other models that are bigger that can handle a lot more data, but also be fast. So Kimi is a good example of this, Kimi 2.6. Qwen is another good example of this, Qwen 3.6. So those Open Router allows you to switch between those using just one API key. So that's a big benefit from Open Router, and the cost is pretty good. So they also have free models. So a lot of models that you can use for free without having to pay anything. NVIDIA also has that, but Open Router, you can switch between the two. Like if you don't like a response from one, you're like, let's switch to this one. I like it better. So that's another way to do it. So when you're prompting, you can always, if you prompt into Claude or Codex, it'll automatically go with OpenAI or Claude because, of course, they have preferential kind of modeling. But then it's important to kind of say, okay, I want this model to do it. And the nice thing is with them, you can also break it down. So it's like I build this app. Can you give me a diagram as to how much one like a case would cost? And it'll break it down based on model and give you the exact cost and the latency as well. So it'll break down the latency as well. So that's the nice thing about it. And then with images, Gemini is usually the best, but recently DeepSeek and Qwen, which can also do images, they also had quite a lot of improvements. So those are actually very cost effective, and you can do thousands of images for like total of 20 cents. So that's very useful with that. And then when it comes to UI and UX, within the prompt, usually it's very good to have like different delineation as to what you're looking for. The more expressive you are as to what you want is better, because if you're not as expressive with this, it'll kind of decide on its own, and then you'll have to go back and make changes. But so initially, if you're like, okay, this is what I'm looking for, this is how I want the user journey to go, or like this is the style I want. Like a lot of people like, the Google style of material design, or they like the Apple style of softer buttons. So those, and like content cards, showcases, so things like that. There's a good resource for that. It's called component.gallery. So I'll put in the chat. So this has like all the different components. So it lists out like this is what everything looks like, and this is how you prompt it. And so this is a good area for UI and UX where you can kind of see, okay, this is like I saw on this website, what is it called? And then it'll do that. Or you can just take a screenshot of that what you saw on the website. That was really nice, and just send it to Cloud Codex Replit, and they'll take care of it. Yep. And then as far as so that was the biggest thing. And then this is the prompt for the LLM itself within the app. So that's another very important thing. So if you're not getting good results from that, so you can adjust the prompt. So this is a very basic prompt that it used. So I'm actually not a fan of this prompt that it has for the system. So this should have like within the constraints, it instead of flagging the missing critical information, it should say, this is why, and then categorize it so that you have a different idea. So why it's missing. For medications, you can also, so what you can do is take this and go into Claude, take the prompt itself and go into Claude and work on the prompt. One thing to note is Claude, GPT, and all the different LLMs are respond very differently to the same prompt. So it's very important to adjust that prompt based on who it is, what the model is rather, not who. And that's another big thing. Yep, and yeah, so that was essentially the prompt, like just to break down kind of the different components of the prompt. And then, yeah, any other questions at all?
There are a couple on the
Sure.
Slido. So I think you kind of touched a little bit, but says, can you briefly summarize the key components required to deploy a prototype that requires storage backend into a web phone app, example API, while minimizing costs?
So the database is probably the most important component. So the database is where all that memory lives. So imagine if you had an app without any database, anytime you can put everything in the app. So if it's a phone app or if it's a web app, everything will live in the browser. So it's what we call browser side memory. So, but the thing is, once that's refreshed, that'll all go away and won't be in the cloud or it won't be anywhere else. So for storage, you always want it to be in a database. And the way the databases work is that basically they'll so depend. There's two types of database. There's a SQL database and there's a Postgres database. A SQL database is kind of just your regular stuff. So like if you say you have the login or authentication on the app, that's stored in like this the username, this is the password, this username is the password. Versus another Postgres database is what we spoke about earlier, where you can have PG vectors, which are basically kind of how the LLMs remember things. And that's what you would need to have for the app. And for a phone app, it would be usually for a phone app or web app, it's the same database usually. So it doesn't matter. So Replit actually, you can make using their database, you can make a phone app and a web app at the same time on the same interface. So it's really nice from that perspective. Cool.
Do you see the next question there?
No.
Oh, okay. So the file that you were just going through with all the details of your app builds, that was created through a conversation with Claude.
Exactly.
And then you copy the whole thing and paste it into Replit to build the app?
Exactly. Yeah. So exactly. So it's all built. It's all done in Claude. You can actually go ahead and build it in Claude. It's just for us it'd be easier to do it in Replit, but you can also do it in Claude, and you would have to take care of all the like the database and all of the other
Right.
things. Cool. And then I wanted to show the website as well. This is the site. Yeah. So I made a site for the webinar, and so basically this is the hub and resource hub that we'll keep up, so we won't take it down or anything like that. And this will have the videos and the webinars that we had, and then you can watch the webinar, but also you can go through all the slides and then the app as well. So like for the research or insight, and what I did for each app is basically added like an educational layer on top of it. So there's an AI tutor that's built into the app. So then you can go through and so anytime like you're going through, it'll kind of like give you responses to why we added certain elements and why certain elements were there. And then same thing with the automations, and then it has a whole explainer as to why each component was added in. So hopefully that's helpful with that. And then the other thing in here is just some links to the courses we have on Dr. Vibe, and then the skills that we built. So these are the UBC specific skills that we had. Actually, they're down here. And then so all you have to do is just take these. You download the .md file and just drop it into Claude Code or Claude or Codex, either one, and then it will just let it know that this is a skill file for that I have, and go through and read it, and you can even ask like, what is it? And it'll tell you the whole thing and how do I use it. And then you can refine it, improve it for your use cases, wherever it is that you would want to use it. And then same thing. And then these are all the different CDS tools that we discussed and the different research tools that we have. So these are all the API links to them. So you can bring all those APIs in quickly. Um, cool. And yeah, so and then I'll add the slides for this third one as well. And what I'll do is I'll do a breakdown kind of making the app, doing the prompt, adding the APIs for a clinical tool that we built, and then I'll post that on here as a webinar as well, just so just so it's easier to follow because I know the reason I didn't build any apps today was any app we would build right now it's very slow. I don't know why all the LLMs are super slow, so it would take at least 45 minutes to an hour and a half or so.
No, thank you for creating this nice resource educational page for our group.
Yeah.
I think we just have about 5 minutes left, so we can look at questions, or Omar, if there's anything else you wanted to show before we look at some questions.
We do questions. I'd
Okay.
be happy to answer them first.
Oh, okay. Okay. When you define the LLM as open router, which is using multiple LLMs, then your app will choose which to use while running the app. Question.
Yeah,
How does it work?
that's yeah, that's a good question. So it can do both. So you can, but the second part, like having it decide, is a little bit more complicated. You have to actually have another LLM decide that for it. Or so the best way to do it so is when you're building it, you can kind of decide and kind of go through the different models and see which one is best. So what I like to do is when I'm building an app, I'll just take like the four I usually go with either ChatGPT or GPT 5.5. Claude has like if you're doing really heavy medical stuff, Claude has something called Claude Scientific, which is like an API that's optimized for that, which pulls from PubMed, it pulls from different places like that. But it's very expensive, it's like $15 for a million tokens. Or I'll go with DeepSeek or Quen. Those are usually the ones I like. So and then you can just break it down, based on this, based on my just ask it, like based on my app, where do you think what model is ideal, and what is going to be the cost if I add it in, and it'll do that, and then you can decide at that point. And then that's the best way. The second way is possible. It just becomes it's like you have
Okay.
to make it agent.
Right. So you're saying we should define or ask it to define like which they recommend to use and then also like tell you what the cost would be. Okay.
Exactly. And you can do fallback. So the other reason I like open routers, what you could do in the app is just have different. So a good example is um, Claude sometimes has peak price charging. So for those hours, you can say, okay, use this model, and then use the other model instead. And then the another crazy way of doing it, if there's not enough permutations, is that you can actually have dual model use. So like if there's any kind of medical clinical decision making going
Mhm.
on, then Claude Scientific is doing it. But anything else, like so if there's a conversation going on, like with a
Yeah.
patient's conversing with an AI, so it can actually the first person they're talking to can be actually be like a DeepSeek, and then DeepSeek will be like, oh well, this is a medical thing. I'm gonna ask
Mm,
Claude, and then get the response back, and then so that's you can layer down like that as well. So
interesting.
then package it up.
Okay, there's another question about the skills that you had developed and said we could download and put into Claude. Can those also be added by Copilot, or is that not a function?
Yes, I think Copilot recently started having skills. So
Oh.
Copilot has skills. They all have skills at this point, I believe.
Hmm.
Gemini and even if they don't, if you take that markdown file and drop it in, it'll be able to process it. And they don't have skills, but I think they have plugins as well, so it'll convert it to a plugin, so if it needs to.
Great. Hey, I don't see any other questions, but we do have 1 minute left. I know you covered a lot of content over the last 3 sessions, so really appreciate you walking us through. I can tell you have so much knowledge and expert experience with this. I think for some of us, maybe who are new or have to maybe take the time and practice and just try it out. And I really appreciate all the starting stuff that you provided for us here. So with that,
Thank
we will be sending some emails out to the attendees of all the sessions with all of the videos and the resources that you've provided to us. If there are any other additional questions, I think you can email us at dash.coordinator@ubc.ca and we can maybe follow up with Omar if there's anything that you can clarify. But we hope this kind of is the start of everybody's journey into, you know, creating different apps, being a vibe coder and like really helping support your work to be more efficient. And yeah, we hope you enjoyed this series. And I just want to say thank you so much, Omar, for being our tutor instructor for the last 3 sessions.
course. It's a privilege. It's been really fun. So hope everybody learned something and yeah, just try it and just all I say is just type in the box and then you'll be see where it goes.
Great. Thank you so much, everyone. I hope you have a great rest of the day.
Yeah.